In this lesson, I want to talk to you guys about intensity of waves. Now, the intensity of a wave in everyday language basically means how high is the wave. So, of course, waves with greater amplitude means that they are more intense. Now, let's go ahead and take a look at a couple examples, A and B, and see what the heck I'm talking about. So, say we were looking at wave A, and it kind of looked like this right here. Pretty normal wave if you ask me. But then we looked at wave B and it looked something like this. As you can see, what we know so far, the wavelength distance from here to here is basically the same as here to here, and also the frequency, how many waves per second or how many cycles per second are the same. However, the amplitude or the distance from this point to this point is the only thing that's different in wave A and B. Now, of course, the greater amplitude means greater intensity, so if we were looking at these waves, we would say that wave B was more intense than wave A. So why am I talking to you guys about this when I should be talking about sound waves? Well, actually, sound waves have a lot to do with sound intensity, especially with humans, because whenever a sound wave is more intense, humans perceive that as a louder sound. So just to give you guys an idea of, how intense is what, sound waves are often measured in something called decibels, dB. You probably heard of it before. Now, people talk normal conversation at around 60 decibels. Is basically what I'm talking at right now, around 60 decibels. Now, if I was to whisper somewhere like this, then I would be whispering at around 20 decibels. And a rock concert is around 115 decibels. So that's when it gets really loud. That's a general idea of what a decibel is and how much basically each decibel is. Now, aside from that, I also wanted to point out that waves decrease intensity with distance. So remember our example where we threw a rock into the middle of a lake? Well, this rock obviously, whenever we do that, is going to cause ripples around it, and around it in a wave pattern. Now, whenever you drop a rock into a pond, like I said, it causes ripples, which are these things, these blue things, or waves in the water in a circular pattern. Now, as the waves move outward, then notice what's going on. First of all, what they're doing is they're getting bigger and bigger, but the intensity of them is getting smaller and smaller, or they're becoming less and less intense as they move outward. Why does this happen, you ask? Well, this happens because even though the inner ripples right here have the same amount of energy as the outer ripples right here, the bigger ripples are more spread out and the energy therefore is more dispersed. So that's why the intensity of the waves decrease the further they are away from the source, which is this rock right here. And also, on the concept of sound, going back to that, that's why music sounds louder the closer you are to the speaker, because sound moves in all directions. In 3D, it's kind of like a speaker is the source, and a sphere would is basically what sound would look around it if it was coming in a wave form. So when you're real close to a speaker, the waves might look, well, let me go ahead and draw you a little graph here. When you're real close to the speaker, the waves might be really intense like this, right here. However, when you're really far away, even though they're the same types of waves with the same frequency, the same wavelength, it's essentially the same sound. It's just not as intense or not as much energy in those sound waves as before.